Question 36. Evaluate the integral of 4s minus 5 all over in bracket s plus 1 in bracket s minus 1 ds. Solution. Split 4x minus 5 all over s plus 1 in bracket again s minus 2 into its partial fractions. We now have 4s minus 5 all over in bracket s plus 1 in bracket s minus 2 is equals to a over s plus 1 plus b over in bracket s minus 2. We now have, if you find their LCM, which is a in bracket s plus 1 times in bracket s minus 2, then the numerator, that is when s plus 1 cancel s plus 1, will be left with x minus 2. Then for s minus 2 times a plus b times when s minus 2 times the cancel s minus 2 will be left with s plus 1. Therefore 4s minus 5 is equals to a in bracket s minus 2 plus b in bracket s plus 2 plus 1. If you put s is equals to 2, we now have 3 is equals to b, 3b. Therefore a is equals to 3. Therefore if you substitute into the equation, we now have 4s minus 5 all over in bracket s plus 1 times another bracket s minus 2 is equals to, our a is 3 over in bracket s plus 1 plus our b is 1 over in bracket s minus 2, which we now have the integral of 4s minus 5 all over in bracket s plus 1 times in bracket s minus 2 ds. Therefore the integral of the partial fractions in bracket s 3 over s in bracket s plus 1 plus b, which is 1 over in bracket s minus 2 ds, will be integral of 3 over in bracket s plus 1 ds plus integral of 1 over s minus 2 ds by after opening the bracket. Therefore the answer will be 3 in bracket s minus 1 plus 1 in bracket s minus 2 plus c. Question 37. Evaluate the integral of 4s minus 43 all over in bracket s minus 5 all squared dx. Solution. 4s minus 43 all over in bracket s minus 5 all squared, when put into partial fractions, we now have a over x minus 5 plus b all over in bracket s minus 5 squared. Then since our LCM is in bracket s minus 5 squared, 5s minus 5 divided by s minus 5 squared will give us s minus 5. Then s minus 5 squared divided by s minus 5 squared will cancel out to give us b. Therefore we now have on the numerator a bracket s minus 5 plus b. Then equating the numerators, we now have 4s minus 43 is equals to a in bracket x minus 5 plus b. To eliminate a, we put s equals to 5. We now have minus 23 is equals to b. Therefore 4s minus 43 is equals to a bracket s minus 5 now minus 23, since we have gotten our b to be minus 23. Then to find the value of a, we now put s is equals to 0, so that we now have minus 43 is equals to minus 5a minus 23. Therefore 5a is equals to 20, a is equals to 4. Therefore a is equals to 4. 4x minus 43 over in bracket s minus 5 squared is equals to, now substitute for a, which is 4 over in bracket s minus 5 minus, we now substitute for b, which is 23 over in bracket s minus 5 squared. Therefore if we now integrate 4s minus 43 over in bracket s minus 5 squared ds, we now have the integral of 4 over in bracket s minus 5 ds minus integral of in 23 over in bracket s minus 5 squared ds, which will now give us 4 in bracket s minus 5 plus 23 over s minus 5 plus c. Question 38. Evaluate the integral of 2s raised to power 3 minus 2s squared minus 2s minus 7 all over s squared minus s minus 2 ds. Solution. In this case, the degree of the numerator is higher than the degree of the denominator. We decide to make the expression a proper algebraic fraction by dividing 2s raised to power 3 minus 2s squared minus 2s minus 7 with s squared minus 2 minus s minus 2 by times with 2x. We now have 2s 3 minus 2s squared minus 4s, giving us, if we minus after subtraction, 2s minus 7. Therefore 2s raised to power 3 minus 2s squared minus 2s minus 7 over s squared minus s minus 2 is equals to 2s plus 2s minus 7 over s squared minus s minus 2. We split 2s minus 7 over s squared minus s minus 2 into its partial fraction. We have 2s minus 7 all over s squared minus s minus 2 is equals to 2s minus 7 all over s plus 1 in bracket, another opening of bracket, s minus 2. Therefore we now have our a over s plus 1 plus our b over s minus 2. If we find their LCM, which is s plus 1 in bracket, another bracket, s minus 2. Therefore, when s plus 1 cancel s plus 1, we'll be left with s a times s minus 2 plus, for b, when s minus 2 cancel s minus 2, we'll be left with s plus 1 times b. Therefore, on the numerator, we have that 2s minus 7 is equals to a in bracket s minus 2 plus b in bracket s plus 1. If you substitute or put s is equal to 2 to eliminate a, we now have minus 3 is equals to 3b. Therefore, our b is equals to minus 1.